All right, so we're faced with this problem asking us to do some balancing of chemical equations. Now, at this point, I'm not going to use any of the simple methods, by simple, what I mean is the beginner methods of writing the list of atoms down and counting each individual atom and having a list of those atoms as we go along. Students should eventually get to the point where they can balance a chemical equation without needing to write down a list of the atoms. And so I'm not going to do that in this exercise. Also, the thing with balancing chemical equations is that there isn't really a surefire method. Well, there is one surefire method, and that's using algebra. You can actually write a series of algebraic equations for each element in order to algebraically solve for the stoichiometric coefficients. That's certainly something you can do. I don't recommend doing that as a rule because the most part, what you're doing with chemical equations is you're balancing them in order to solve some other problem. And so a chemistry student is really only doing balancing of chemical equations in order to then answer other questions about stoichiometry or other types of chemistry problems. So 9 out of 10 or even 95 out of 100 chemical equations that you see can just be balanced by using some consistent ideas. And the consistent ideas are the following. Usually approach the most complicated looking formula and start there. Save oxygen and hydrogen till the end. Save individual elements that are by themselves until the end. Start over often, just like if you get stuck, just erase all the numbers and redo the problem from the beginning. And the other thing to do when you really are struggling is to just try brute force. And brute force means let's just randomly put stoichiometric coefficients in front of a particular element and see if that helps. And very rarely will you get into a situation where you need to do that. There'll be one example in this problem where that's really the way to go. But by and large, you can do every other chemical equation balancing with just kind of those first couple of tips. So let's start off with A here. If I were looking at this problem, I would look at the aluminum sulfite and say that the aluminum sulfite looks like it's the busiest equation. And so I would say, look, looks like I have 2 aluminums on the reactant side, so I need 2 aluminums on the product side. Then go from there. I wouldn't try to deal with oxygens and hydrogens right now. I would try to do something else. What I do notice is that sulfate and sulfate don't change formulas. And since they don't change formulas, I can balance them as an entire unit. So in other words, I have 3 sulfates here, and so I can make 3 sulfates there. And now the sulfates and all of the oxygens that go along with them are balanced. So let's take a look at sodium. There's 6 of them, so I'll need 6 of them here. So 6 on the product side. Now I've got 6 on the reactant side. And now that I've got everything taken care of except oxygen and hydrogen, I can go back. 6 OHs, 2 times 3 is 6 OHs. And so I'm all balanced up here. Okay, moving right along. This one's pretty straightforward. I've got 2 irons on the right. And so I need 2 irons on the left. I've got 2 aluminums on the left. So I need 2 aluminums on the right. And I'm going to use left and right to refer to products and reactants. Reactants will be left, products will be right. So let's take a look at the next one. The next one is going to require, get you into a situation, what I call even odd. So in the even odd situation, everything is balanced except for oxygen. But the oxygens on the left come in an odd quantity, an odd grouping, and the oxygens on the right come in an even grouping. So whenever you're in an even odd situation, my suggestion is to just go ahead and double everything. Once you double everything, then you can take another look at the problem and you can start to see that now I've got 6 oxygens here and I need to make 6 oxygens there. And so instead of a 2, I would use a 3, and now everything is balanced. All right, so moving along, I've got the next one is got some sodium nitrate and some N2O and H2O. And it looks like I've got everything balanced. I've got 2 nitrogens on the left, 2 on the right. I've got 3 oxygens on the left, but I've only got 2 on the right. I've got 4 hydrogens on the left, 2 on the right. So actually, I think I'd start there. That gives me 2 times 2 is 4 hydrogens. Now the hydrogens are balanced, but look what it did to the oxygens. I've got 3 and 3 now on both sides. So 1 step and done there. Okay, next I've got this guy for E. I think what I would do is I would start off with the sodium hydrogen carbonate. That's looks like the most complicated formula for me. It looks like I've got 1 sodium on the left, but I've got 2 sodiums on the right. So I'd try this first. Now the sodiums are balanced. Let's check everything else. So it looks like I've got 2 carbons on the left and I end up with 2 carbons on the right. So that's okay. I've got 2 hydrogens on the left and it looks like I've got 2 hydrogens on the right. So that's fine. I've got 3 times 2, that's 6 oxygens on the left. And I've got 3, 4, 5, 6 oxygens on the right. So it looks like I'm done. What about the next one? The next one, I would start off with the phosphorus. Now, in this case, you have phosphate on the right, but you don't have phosphate on the left. So you can't balance the phosphate as a unit. So you have to break down the atoms individually. But I do notice that I have 4 phosphorus on the left, only 1 on the right. So I think my first move would be to put a 4 here. And that gets my phosphorus balanced. What did it do with my oxygens? I've got 4 times 4, that's 16. And I've got 10 on the left. And so, and plus 1, so that's not quite balanced. So if I put a 6 here, then I would have 10 oxygens here, 6 oxygens there. That would balance out with the 16. Let's go back and check now the hydrogens. 4 times 3 is 12. Oh, and 6 times 2 is 12. So I'm good there. So I'm done with that one. Okay, what about aluminum? This aluminum situation. I'd say that, again, I would look at this formula and I would say that's the most complicated looking formula. I might want to start with those atoms and elements. I'd also notice that sulfate is a unit there. It doesn't change as through the course of the reaction. So I can balance sulfates individually. So let's just go ahead and start with aluminum. 2 on the right. Now I've got 2 on the left. Sulfate, I've got 3 times 1. So I got 3 there. So let me put 3 there. Looks like I'm doing so far so good. Now hydrogens, 6 on the right. Now I have 6 on the left. I'm all set with that one. Okay, let's take a look. Looks like beryllium is not balanced. It looks like carbon is balanced, and it looks like hydrogen is balanced. I've got some problems with oxygen. I only have 2 of those. Oh, hydrogen is not balanced, so I got to deal with that. But I think what I'd do is I'd start with the beryllium in this case. I've got 2 on the left, so let me put 2 on the right. I'm going to save those oxygens and hydrogens to the end. I'm still good with carbon, so maybe now it's time to work with the hydrogens and oxygens. So let's count hydrogens. I've got 1, 2, 3, 4. And I've got 2 times 2, that's another 4. So I have 8 total. So in order to get 8 on the left side, I would need a 4 here. So hopefully that took care of the oxygens because that's the only option I have. Let's count them up. 4 times 1 is 4. And 2 times 2 is 4. It looks like I'm good. I'm done there with that one. Okay, what's next? It looks like I've got something looks pretty complicated. The sulfate does not stay a sulfate. So I want to go ahead and deal with the individual atoms for that one. It also looks like nitrate does not stay nitrate. So I have to deal with individual atoms everywhere. This one is a little bit harder to figure out where you need to start. And the reason is that pretty much everything is balanced. Let's take a look. I've got 1 sulfur and 1 sulfur. I've got 1 nitrogen and 1 nitrogen. So the next really is to deal with oxygens and hydrogens. Well, how do I do that? Let's take a look at the oxygens and the hydrogens. I've got 4 here and 4 here. Excuse me, 2 and 2 is 4. So I think that's what I'll do now is I will use a 4 to make the numbers of hydrogens equal. I know that that's probably the good place to go because on the left side, there's only one place for hydrogens. So that one stoichiometric coefficient has to balance hydrogen across the whole reaction because it only appears in one place on the reactant side. So let's count up then what happened with the nitrogens and the oxygens. Well, that did change the number of nitrogens. I had 4. And so now I need to come over here and make this 4 so that it balances out as well. So let's recount now. Let's deal with the oxygen. So the sulfurs, hydrogens, and nitrogens are good. I've got 3 times 4, that's 12 oxygens. And I've got 4 plus, let's count this here. 4 times 2 is 8. So that's 12. I got 13. And look, I did forget to count this oxygen over here. So it's 13 and 13. So again, 1 plus 12 is 13. 8 plus 4 is 12. Plus 1 is 13. So I'm all set there. So all balanced up, 4 and 4. All right, so let's do this next one. Ammonia plus copper 2 oxide yields copper, nitrogen, and water. So in this case, it looks like I would start off with the nitrogens because they're not balanced. And the only way to balance the nitrogens on the left side would be to use a 2 there. Coppers are balanced, oxygens are balanced. It's just hydrogens I need to work with. So let's try that. Looks like I've got 6 nitrogens, or excuse me, 6 hydrogens here. So I need to do something there to make 6. It looks like I'm going to need a 3 there. Okay, so that did change the count on oxygen. I now have 3 oxygens. And so I need to come over here and do 3 there to get it. Whew, and now that unbalanced the copper, but that is easy to fix there. So up to this point, everything was really straightforward. There wasn't a lot of things to consider. There's just some stepwise advice on how to approach these problems, but by and large, they're pretty straightforward. This last one isn't going to be straightforward. It seems like it might be fairly easy to deal with because I've got some nitrate here, I've got some nitrate here, I've got a copper and I've got a copper. Let's try our method that we did before. Well, I have 2 nitrates, but the problem is I also have an NO. So there's other chemistry that's happening here. If I just come over here and do this, I'm not balanced. But let's try 3, because I do have 3 nitrogens total, and that might start in a good spot. Okay, well, what happens now? Let's count up our oxygens. I've got 9 oxygens here. I've got 2 times 3 is 6, 7. I've got 8 there. So I don't really know what's going on. Maybe I should skip oxygen for the moment. Let's try hydrogen. So I've got 3 hydrogens there. And I've got 2 hydrogens here. Oh, that's an even odd situation since the only place that the hydrogens are located comes with in one species on both sides. So let's try our normal even odd solution. Let's multiply everything by 2. So I'll put a 2 there, a 6 there, a 2 there, a 2 there, and a 2 there. Everything would still be exactly the way it was before, just in twice as many of them on each side. So let's go back and let's take a look at our nitrogen just to be sure. 6 there, 2 times 2 is 4 plus 2 is 6. Okay, I'm good there. We said we were going to worry about oxygens later. I've got 6 times 3, that's 18. And I've got 6 times 3 is 18. Then I've got 6 times 2 is 12, 13, 14, 15, 16. They're not balanced. I'm not sure what I need to do with that. So let's go back to that hydrogen. That's why we did the even odd situation. So I've got 6 hydrogen here. How do I get 6 hydrogen on this side? Well, I would make this a 3. Okay, so I think at this point, coppers are balanced, nitrogens are balanced, hydrogens are balanced, but now we got to deal with oxygen. So I've got, again, 6 times 3 is 18 oxygens. I've got I've got 6 times 2 is 12, 13, 14, 15, 16, 17. So oxygens aren't balanced. And so I don't actually know what to do at this point. This is an example of when things are just not working out. And so you do have to just try some brute force. And brute force means, well, let's just kind of start over and change things and let's see if we can make them work out. So I'm going to back up and I'm going to erase every stoichiometric coefficient except for the first one. Well, we've already tried the copper with a 1, and we've already tried it with a 2. Let's try it with a 3. So let's see where that gets us. Okay, if I put a 3 there, then I need a 3 there. All right, well, we know that the nitrogens are in more than one place, so let's try to count those up. It looks like I've got 3 times 2, 2 times 1 is 2, times 3 is 6. I've got 7 there. So that doesn't actually work. Let's try something different then. Let's try oxygen. Now let's try our, whew, boy, things are just getting crazy. Okay, let's go back and let's try. Let's try our nitrogens. Let's sort it out. 1, and then I've got 6 plus 1 is 7. So let's try that. So let's put a 7 here. And let's work on the oxygens. Looks like I've got 7, that's 21. 21 here. I've got 3. Oh, what's going on here? 6 times 3 is 18, 19, 20. Oh, well, maybe I could get 21 if I put a 2 here. Now I've got 21. Oh, but now I've messed up the nitrogens. I added an extra one. So let's go back and make this 8. So now I've got 8 nitrogens. And then I've got 3 times 2 is 6, 7, 8. Okay, I'm good there. Let's try that oxygen again. 8 times 3 is 24. So I got 24 there. I've got 6 times 3, that's 18, 19, 20, 21. But I could make it 24 if I just do this. So now I've got 24 plus 4 plus 2, that's 6, and 6 plus 18, that's 24. So the oxygens are balanced. And then let's try one. Let's try, oh, wait, everything's balanced now. the nitrogens are balanced, the hydrogens are balanced. Let's take a look. Here's the last one we were working with was hydrogen. There's 8 hydrogens and 8 hydrogens. Okay, and so I wanted to make it seem like I was stumbling around a little bit. Of course, I had this solved before I started the video, but I did want to work you through kind of the stumbling through it process. Out of the 11 problems you had to balance, most of them were straightforward, but occasionally you might find one that is really difficult. And then you have 2 options. You can rely on an algebraic solution if you know how to do that, or you can just try some brute force. And what you should do is rest assured that if you're going to need a chemical equation for a problem, 99 out of 100 instructors will either give you an equation that's easily balanceable or give you an equation that's already balanced. And so I hope that helps, but that's it for this problem.